Hello, is this thing on? Okay, it is. Phew. Here goes nothing. Today we're going to study more mathematics, namely, I don't know, linear independence or line independence. So, just as soon as I crack open the textbook. Okay, but however, I didn't finish my stuff. Okay. Yeah, okay. Also, what a terrible system I have. Okay. Is camera gonna work? Yep, that looks pretty good, I think. Okay. Alright, yeah, this will probably okay. Okay, 9.9. Or just the topic of independence path. Okay, after I finished screaming before I went to bed, and then I woke up. And now we can get to work. So basically what they're trying to say is they're trying to say, you know, you have a function fxy which is equal to pxy I and qxy I. Okay, whatever, you know, p and q. You separate them and then you have r at t, which is a function of a parametric equation f of t I plus g of t I or j between a, t, and b. Get the idea, right? Now they're saying a curve can be written as p dx plus q dy is also equal to the function times the derivative of r. So you take this and you derive it, and then you can multiply by there. And I think it's a performance of the cross product or something, the dot product, which means that you multiply I times I and j times j. Maybe that's not what it means, but that's what I think it means. So we assume that the path of integration lies on the region or something. I don't really know. So now we look at our path independence and the integral y dx plus x dy. Oh, I should turn the light. Between 0, 0 and 1, 1. So you may recall. Okay. Hold on. You're supposed to recall that that's equal to that, and you're supposed to verify that they all equal 1. So in the following curves, let's say this guy goes here, and goes up here. This is one line segment. Here's another line segment from 0, 0 to, this is x, right? So it's 1, 0, and then 1, 1. So from here to here, what is it? Oh, hold on 1 second. Excuse me for a moment. Okay. Okay, so this goes from 0 to 1 and 1 to 0, so since this is changing along the x-axis, we can call it x. Well, you know that, x equals 1, dx equals 0, right? Because it's changing by 1. So then you go over here and you say, you look at it, dx is 0 and x is 0, so you know that it's 0. And you know that anything going across the line is 0. Over here, it's 1 to 1. And we're going to focus on y because it's changing in the y direction. So y equals 1 and dy equals 0. So since dy equals 0, this part's going to equal 0, but this part's not going to equal 0. This part's going to equal 1 dx. And then you do it from 1 to 0. Or 1 y dx. Y dy, and dx is 1. So it changes to dy somehow. Not really sure about that. You do it, you get half y squared minus half y squared. And it's supposed to equal 1, but it doesn't look like it equals 1 today. So I probably got something wrong. This equals 1 over 2. That can't be right. Okay. I was wrong again. Okay. There's nothing I can do about that. But let me think for a second. I got no idea. Because I guess I'm not very intelligent. Potential function and the conservative vector field. The integral in example 1 can be interpreted as a line integral of a vector field f along a path C. If fxy equals yi plus xj and dr equals dxi plus dyj, then blah 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 f times f dot dr. Then they're asking you to consider the function. This thing is called phi. It's a Greek letter. And we use in mathematics because we run out of letters. There are plenty of letters I've never used before, like S or Q. Actually, no, we use Q. Maybe T. It's T for time. E, F, E. We never use those, so we do use F. Wow. We use a lot more letters than I thought that we did. So what they're saying here is phi over dx, phi over dy equals y I plus xj, because you're taking the, I guess I don't know, you're taking the something. You're taking the gradient. Okay, of course, not every vector field. Blah blah blah, path independence. Oh, I should really be focusing. Can't there's some delicious apples that my mom cut for me. Right in front of me. Can I eat them? Is it okay if I eat them? I take a 15-hour break to eat my apples. Path independent. Value of a line integral is the same for every path, then it's said to be independent. I have no idea what any of this means. The fundamental theorem of path independence. Here's what I've been looking at. E, A, f prime of x equals f of b minus f of a. Okay. In a manner that is akin to the fundamental theorem of calculus. The fundamental theorem for line integrals. I really don't know what these guys are talking about, because I think I'm about to be in for a world of hurt. However, you work hard, it's not gonna betray you. They say that hard work will not betray you. Probably. Okay. Suppose C is a path in region R of the xy plane, defined by RT equals xt plus ytj. ATB. Okay, so everything I basically talked about, and this is the fundamental theorem of line integrals. The gradient of phi multiplied by dr equals phi b minus phi a. They're telling you if you take the gradient of whatever's in here and then you multiply by the derivative of r, which you'll have the function of r and you just have to derive it, you can find the phi of b minus phi of a, probably. Where a equals this. I think I already went over this part on the stream. But you know what? I probably didn't do it correctly because I don't remember any of it, so now they're proving it. The proof. I don't know. I don't know what the proof is, even though it's right in front. Of the chain rule, it follows that f times d of r, d over a. Stuff is so complicated. For piecewise smooth curves, the foregoing proof. Oh, I forgot to introduce my picture that I drew. So this is from some game called like Peru on Hataku. I don't really know actually. I saw a thumbnail on YouTube and I drew it. So basically it's really rushed and it's bad because like I didn't care. So let's make it a little smaller until we get out of here. Osaka, 1 picture, 2 pictures, 3 pictures of Osaka. How many could there be? Just made small. Here are a lot of pictures. Okay. Back to the. So just me, small, down like. Might be a little better. Oh, now I can't see the stupid text because the camera's in front. Okay, what? BA. dr is equal to BA. Gradient of phi dr. Example 1 revised again. Okay. If you do the gradient, then don't you have to do like x and y and you have to derive them? Or so otherwise, why is it going away? Like, look. On. Okay, what if I just move this, like I put it? That wouldn't work. Okay. I'm just gonna have to deal with it. A conservative vector. I have to go get another source for this. C y dx xd was the integral of 1 1 0 0 f dot dr was 1 1 0 0 gradient times dr. Basically, how did they figure out that it was x and y? So how do they know that it's a potential function? Because I think if you, well, actually, if you take it from y, x, you get dx plus dy. If you integrate it, then you get x plus y. That's not really how it works. Okay. I have to go up and look at something because I just feel like I don't get it. Okay. Yep, I gotta Google some stuff. I go to pause math notes. The fundamental theorem for line integral. This is a fairly straightforward proof. All you need is the final points and the initial points, and then what you can do is the dot product or something. Give to. It's not how it works. I eat an apple. Apple break. I used to go to Vietnamese class because Vietnamese. Then the teacher would cut apples and be like, apple time, and we'd all go get apples to eat. I really hated going to that class, but that was like a nice memory. It always tastes really good. And before, when I was little, I used to think that because the classes cost like $20, like for the whole year, $40 or something, I thought the teacher only got paid like, like $40 per person. There were like 20 people, so I thought they only got paid like $800 or something. Is it 800? Yeah, it is 800. It's like for the whole year. I was wondering like, oh, how do they buy like materials and stuff? And to be honest, this wasn't in like grade 2 or something. This was like in grade 6. So I was like a dumbass. So I guess, makes sense looking at me work now because I'm really stupid. Also, I didn't learn anything in that class because I was always goofing off. The teacher like would just kind of just let us goof off because like we'd sit around and we would go like, okay, let's recite the Vietnamese words, and then I didn't know how. Like I didn't know what they meant, and I didn't know how to say it. And like the teacher, basically, she would like do for the whole group. So like basically, I just didn't know. So like it was just really like terrible, basically. And well, I had a few friends, but like I basically just wasted like hours of my life that I could have spent like doing homework or something, just like spent at home. But like if I think about it, it's like like what if I joined a club or something instead of doing that? But like it was only one Tuesday. It was one day per week. So really, was it really that bad? And I was on like the track team too. I was like running around. I did get my exercise, but like damn. I had a lot of fun on the track team actually. I didn't have any friends, but like I got to like run around. Like running around really helps you like, do your thing or like kind of like be it gives you time to think. So I'm kind of a big fan of running on the treadmill when I go to the gym. Like a hamster, I guess. Or just a normal person who likes to run. How about that? Okay. Anyway, I'm still looking at this and I can't figure it out. Like I must be really stupid. I must be exceptionally dumb. Okay. So here's what they're saying. They're saying that RA, like over here, RA equals 1, 1, and RB equals 0, 0, right? So what they're trying to tell me is that the function cosine 2 pi, or they're not trying to tell me that. They're trying to tell me that it's like this. So this is y dx plus x dy, right? Now they're telling me it's minus y dx plus x dy again. But this time the whole thing's here. So now that you have your a 1 1 and your b 0 0, you plug in 0 here for this and you plug in a here. So give me a second. So here's 1. So here's dx plus dy. And here it's going to be 0 0, right? It's going to be minus 0. But whatever, it goes away. So now you have your dx and your dy. Okay, so now what you're supposed to do is that. So what was dr? Oh, this is dr. Okay, so now you take it and you're supposed to, you have your dx and you have your dy. And what do they equal? Well, since they're 1, then it just equals 1, right? That's literally not true. So I have no idea. I'm stupid. Getting mad. Okay, let me just eat an apple to relax after all that yapping. Okay, that was quite delicious. That hit the spot actually, as a matter of fact. Now apple's like all stuck in my teeth. I guess it's pretty unprofessional to eat on this. Professional, who cares? In slop. I'm making slop content. When C is an arbitrary path, you gotta choose a point or something. God. Maybe I just can't focus today. Also, I have some economics homework I'm supposed to do as well. It never ends, man. Can I just relax for 1 minute? I did actually. I've been relaxing for like 5 days. Yeah, I skipped like 3 days of school. 2 days, but like basically I skipped like almost all my lectures. Because they're not teaching anything anymore. I should just stay home and study for my exams. Because the first integral does not depend on x. Talking about some die phi over die x equals 0. Oh man. We conclude that f is conservative. Yeah, so I'm going through all this stuff. I'm not learning anything, so I should like kind of focus. Or I should like go back, right? I should go back to look. Gradient of the scalar function. Oh man. To sleep for like 7 hours and it looks like I forgot. Oh, that's okay. How's it been? I streamed like from 3 to 5 or something. Oh yeah, it's been like hours. Ah, idiot. Puppy join, there's multiply connected, so basically they're just drawing some like stupid ass stuff. Over here is like A, so B, A, R, C. It's a connected region. Here's A, B, they're not connected obviously. So a pair of boobs. LOL. To see like this. There's like a hole in here. They're talking equivalent concepts in an open connected region. F is conservative. Yeah, okay. Gotta go look somewhere else. It's not how to do the integral. It's all you gotta do is put the final initial point into the function and subtract the two results. We don't really need to know the path. We could use any path we want and we'll get the same result. Sorry, the remaining definitions are new. FDR is independent of path if FDR equals F dot dr for two paths. Closed, simple, simply connected, independence of path. Easy enough to prove, we just gotta look at the theorem above. Some nice facts to remember. Okay, so now I gotta go practice problems and go look it up. Okay, I'll look at that when I get stuck. Just to reiterate, I'm using Paul's online math notes, so I guess it's to him. I don't know, care. Unless he finds my video and he copyright strikes my channel. Even if that happened, actually I would be sad since I didn't download any of my videos, so they would all be deleted. Okay. I already went here. Equivalent concepts. FDR. I actually have some important homework that I have to do, but literally don't know how to do it. I need to answer 2 more questions and I probably got like wrong. I'm so stupid. I wish I wasn't so stupid. But actually there's a way to remedy that, and it's called working hard, because working hard will not betray you. Next we prove the converse. If I pop this. Pop out chat. Okay. Welcome to the chat room. We prove the converse that CF times dr. E equals 0 for every closed path in R, then FDR is independent of the path. Let C1 and C2 represent 2 paths from A to B. Okay. Blah blah blah. Conservative. I don't know what conservative is. I know it politically. dy or talking about di p over di x I equals di q over di x. So they're saying that if you take the derivative for the function of p, which is the first one, and you derive it by y, and you derive the other one by x, and they're equal, that means they're conservative. Determine whether the vector field is conservative. Okay, so it's x squared minus 2y cubed I plus x plus 5y j. Prove that's conservative. You do di p over di y, so you take the derivative here. Derivative of x squared, it's a constant, so it's 0. Derivative of negative 2y cubed is negative 6y squared. Now you take the derivative of x here, which is 1. 1 here, and then 5y. Does it equal 0? No, it doesn't equal 0. I mean, it doesn't equal the same. But is it true? It follows that f is not conservative. Okay, so I was correct. Determine whether the vector field negative xy, negative ye, negative xyi. Oh, give me a second. One moment. Okay, actually, this one was conservative, so it looks like I got it wrong and I didn't even derive it correctly. Actually, I derived the first part correctly, but this part is wrong. If you're to do this, then you have to do it like this. You take out the x and the negative, so it's negative, or it's positive xye, negative xy. And then this one is also positive xye, because you're pulling the y down. I didn't know that because I did at this game. Example 7, integral that's path independent. So now they want me to prove path independence or something. They want me to show that it's independent of the path. Okay. Let me browse the Twitch stuff. I mute this site. Popped out the chat. Okay. No break. F.dr. So what you're trying to tell me is y squared minus 6xy plus 6y plus 2xy minus 3x squared 2y. The I is j. It's independent of the path between negative 1. So I don't know what this means, basically. Or they're trying to tell me, like, show that it's conservative, and if it's conservative, it hurts. My body always hurts. Pretty sure that means I'm going to die an early death. So this is die p over die y, die q over die x, ends dying. That's good. So let's go look. It's 2y minus 6x plus 0. And this one is plus x. I thought this was okay. So over x, this 2y minus 6x. 2y is 0. So okay, look, they're equal. Therefore, conservative. But like, what does this even mean? Like, so what if they're conservative? I really don't understand. Now they're telling me to to like evaluate FDR. So and find a potential function, but I don't know how. So basically we can do C. So since one function is going to be -1, 0 and the other is 3, 4, you just plug it in. I'm going to use this formula, f dot dr is equal to phi a minus phi b, or like fa minus fb, like this. So now all you have to do is -1, 0. So here's 0 minus 6 1, 0 plus 6. Okay, now minus. But wouldn't they be equal to 0? Okay, let's see. So minus whatever's inside here, which is 2, 3, 4. Minus 3, 3 squared. Minus 2, 4. 2 times 3 times 4 is 6. It's 24. 9. Minus 27. 4 minus 8. I'll give 27 minus 8. Do you guys know that? I give 35. 24 minus 35 is like. But now you have 9 here and you have 6 here. 6 minus 9 is 3. So that's my answer for C, and the potential function. I don't know. I don't know, man. So as a consequence, it's independent of the path. They're telling me that the potential function is with the two whatevers. Then, and it looks like I was wrong again, because I'm an idiot at this game. And I forgot to integrate, that's probably why. Okay, so I'm gonna need some time to think, I guess. Can I have another apple slice? Apple slice, apple slice. Eat really juicy apple to. Okay. I've just been looking at it for a while and I still don't know what's going on. Talk about any convenient curve. God damn. Conservative vector fields in. Yep, okay. So now that I have no idea how to deal with 2D, we're gonna jump right into the 3D space. So di p over di y equals di q di x. Di p over di z equals di r over di x. Wait, is this the same as hold on. Equals di r over di y. So basically it's I j k di x di y di z q telling me. So if you want to do I, you have to do di y over di r over di y equals di q over di q over di z equals di r over di y. Here you do di r over di x di p di z. Di r over di x equals di p over z. Here you do di x di p over di x di q over di x di p over di y. I got it. I think I got it. Probably not. I probably don't understand. I think. I just want to go to double integrals and I'll be better at those, but the reality is I'm not going to be. I have to study a lot. Plus, I have a midterm. Try logging in thing. Okay. Everything's working. Well, guess we're gonna have to move here. Where I was doing all other work, but it's okay. That to happen. Actually need to work on this. Can I just have another app? Apple time. Okay, that was really delicious. You have to get back to work. Okay. Maybe it's because I'm too messy here. They want us to show that the line integral y plus yz dx plus x plus 3z cubed plus xz dy plus 9yz squared plus xy 1 z is independent on the path. Basically what they want us to do is evaluate them, see if they're equal. This is P, Q, R, right? Here's my I, J, K, I, X, die, Y, die, Z, Q. Now what they want us to do is look at I, and you're gonna do dy over R. So here, Y, that's gonna be 9 Z squared plus X. And they want you to see if it's equal to dz over q, or di q over z. Here it's going to be equal to, this is 0, this is 9z squared, this is plus x. So therefore they're equal. Now we gotta check for j basically, so you cover this part up and you do r over dx. So here's r over dx, 0, 0, this is y equals do di z over p. Here's p and you do di z. Also equals y. So they're equal. So you probably get the idea, right? So now you do di x over q, or q over di x. So here's q over di x is 1 plus z. Now is it going to be equal to p over di y? P over di y is 1 plus z again, because root of y is 1 and root of yz is z. So therefore they're equal and they're path independent, and now they want you to evaluate it. So I did something wrong before, so now I'm going to try to fix it, because you're going to have to take the partial derivative of dx. So take it with respect to x, so y gets an x, yx plus yxz, or xyz. Well, I messed it up, but whatever. Plus with, so well, I guess I'm integrating them like all on my own because I can do that. So x plus xy plus 3yz cubed plus xyz, okay, plus, hold on, did I do everything right here? If you do with respect to y, and if you do this one with respect to z, it's gonna be 9 over 3yz cubed plus xyz minus z. So with all of that, this is the whole equation, and now you're gonna have to do 1, 1, 1, and then 2, 1, 4. 2, 1, 4, and then 1, 1, 1. So I guess we're gonna have to do it, or we're gonna have to painstakingly do it. 1 times 2 plus, okay, I don't have to do this, I can just do the mathematics. 1, 1, 2, 4. 2 times 4 is 8, okay? Now plus 2 times 1 is 2, plus 2 plus 3yz cubed. 4 cubed is 4, 16, 64. Times 1 is 64, times 3, 64 times 3, 12, 3, 3 times 6, 18, 19. So plus 192 plus xyz. Plus xyz is 2, or 2, 1, 4, which is plus 9 over 3, which is 3 times y. So 3 times y is 1. That is cubed. So this is 64 again. So it's 192. plus xyz, which is 8, minus z, which is 4. Now you add all that together, you get 10 plus 194 plus 200 plus 8 minus 4. Okay, you take all that, and what you get, this is like basically here is like 202, 402 minus 4 is 398, and then plus 10 is 98 plus 10 is, wow, I'm so stupid. I can't figure it out. 408. Now you have to subtract it by the exact same thing. So 1, 1. So minus 1, 1, which is 1. This is 1. 1 plus 1 plus 1 plus, this is actually 3 plus 1 plus 3 plus 1 minus 1. So now you get minus 1, 2, 3, 6, 7, 10, 11, 10, minus 10. So you get 398 is what I got it to be evaluated as. And if we go down, I'm going to be 100% wrong. I just feel like. It's 194. Hey, can I have 1 W? Can I have 1 win? Is it too much to ask? But in order to have a win, you have to work hard, because hard work will never betray you. Hard work will not betray you, as they say. So let me just eat 2 apples. I'll work my mouth hard. Pause. That. Okay, that apple was especially delicious. Okay, well now I have to go back to hell. And that's it. Those were the last apples, so no more apples. So now they want me to do partial integration, like whatever the hell that means. With respect to x, integrating the first of these 3 equations with respect to x, like what do you mean? What are you talking about? The derivative of this last expression with respect to x must be equal to q. Like, how did you know that? Okay. Now the conservation of energy. See problem 31 in exercise 9.9. Now, we made it to the exercises, but, you know, I don't understand it, so I'm gonna have to go read the whole chapter again. Cause I just don't know what's going on. I got this done in record time, a 1 hour. If I could keep that, I could get the rest done in like 8 hours, but you know, it doesn't really matter how quickly you get it done. You have to understand, am I right? Well, anyway, I have plenty of time. I'm probably gonna stop at like 11:30, which is like in 3 hours. Well, we'll see if I even have the energy. And also, I have 2 questions I have to solve. So after I do that, like basically after I do my homework, I might even stream again. Wow. And it'll be a video game. I'll do more Hollow Knight binding. Anyway, it doesn't matter. Use theorem 9.1. 1. Oh, question 1. 2, 2. 0, 0. U x squared x plus y squared dy. And B, use any convenient point and use theorem 1. I gotta go all the way back up to find what is theorem 1335. Okay, it's just the original theorem that I've always been using. Now what you have to do here is, hold on, I'm supposed to take the gradient, right? So here it's 2x dx. Is this really correct? Now I gotta go look at the fundamental problems, the note. Plus my stomach's starting to hurt now. Ouch. The derivative of x dx equals that. Wow. Okay, so what they're trying to tell me is don't do any of that and just plug it in. 4 plus 4 dy minus 0 plus, and that's gonna give me 8. Okay. 16 over 3. This over 3x cubed plus 1 cubed be 2 times 8 over 3 plus 8 over 16 over 3. How you get the answer, but like how am I like basically what the hell am I doing? Because like I'm just getting like pissed off now. Go here to, so if I follow that theorem, it's not even a theorem, it's just like, okay, it's just like do it. So now you get half x squared plus 2xy plus 2yx minus half y squared. And they're telling me, now they're telling me just plug it in. 3, 2, 1, 0. Okay, so here's xy. 3, 9 over 2 plus 2 times xy. 6, 12 plus 12 plus 2. 2 is 4. 4 times 3 is 12. Minus 1 over 2 y squared. That's 4, right? Okay, 12, 12. 4 over, this is minus 2. This is 24. Plus what is basically 4.5. Then minus 2. So that's 28.5. That's 26.5. And then you have to do the minus part. So this is 0, x is 1, and this is 0. So half x, that's half, minus this is plus 0, this is plus 0, this is minus 0. So now minus a half is 26. The answer is 26. And we're never gonna know because they don't do the answer to even number questions. So now we're gonna go to question 3. And then they start adding, random ass questions. And they ask you, go find the blah 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 and go find the work done. Okay. I have a bathroom break. An hour, right? My bathroom break at 5 minutes. Okay. Right back. 8:37. 3. That's 6 minutes. Whatever. Bonus minute. Okay, hello. Break's over. Break is over. Is this thing even on? Yeah, it's on. Okay. Where was I? Question 3. Oh, sorry, I didn't even write it out. Didn't even write it out so you guys could but you could do it. My mistake. Okay. Let's take the integral with respect to dx, so that means integrate this x squared, integrate this plus 2xy, because you treat it like a constant. Which means that, you know, you pretend it's like 1 or 2 or something, so you just add x to it. This is 2yx minus half y squared dy. Can I just do this question? Did I literally did do this question. Answer is 14. Dummy. 3 and 2. x3 y2. So here 2 plus 2 3 6 plus 12. I did do this question. Fucking idiot. 4. You're supposed to do the other question. Minus 1 where x is half 0. And this is supposed to be 14. Is one of them not like this one? This one. 2. 4. 5. 4. 4.5. 6. But divided by 2 equals 15. But why the hell would I divide by? How the hell did it equal? I hate so much mathematics. Skipping it. A hard one. Okay. Zero zero y cubed. Doesn't matter though. It doesn't matter what question. It's textbook to use a certain site. I'm gonna name. Dy here y cubed x plus x cubed y plus x cubed y plus y cubed x plus. Okay. Okay. 2 and 8. 0 0 means it doesn't matter. X and y. 8. 8 cubed. 64. 64 times 8. 32. 8. 8. 8 plus 3. 512. Times this. 1004 plus x cubed. It's 8. 64 plus 64 plus 8 cubed. 512 plus 4 plus 2040. Like that game. 120. It's like that. It's like that one game. Anyone know hit game where you like move the boxes together or some shit like that? I mean, some shenanigans like that. 2184 and minus 0 is go here and you look and it's 1096. Really hate myself. I think I'm gonna fucking what? And then you divide it by 2 and it's 1096. But why would you divide it by 2? And it's not even 1096. So obviously I'm missing a core fundamental of the I'm missing a fundamental aspect of the problem that makes me be correct. So unlike line integrals, I don't even know what I'm doing. In the whatever, determine that if it's a conservative field, and then I'm gonna look at the do work. I always feel like I have to take a break. Don't. I should keep going. fxy plus 3x4 y squared 1 x and j. So in order to find the potentiality, or in order to find the whatever, a little bit of what I call gooning. That's what it's called. Go to your teacher and tell them that you're gonna goon when faced with a difficult so die whatever. This is 12x cubed y squared plus 0 plus here is 12x cubed y squared plus. Therefore they're conservative since they're equal to each other. So now if you go to 11, they're gonna tell me find the equation. So now what I'm supposed to do is take this with respect to y, or I'm supposed to take the integral with respect to y or x. So let's do it with x. So x4 y cubed plus x plus, then it's gonna be plus like xt or some shit like that. Now I don't know what. Now I don't know what. This part is right, and the last part is supposed to be y, but I don't know why. It's supposed to be y, but I don't know why. It's supposed to be y, but I don't know why. It's supposed to be y, but I don't know why. Anger. In problems 17 and 18, we're supposed to find the work done along the indicated curve. What if I just took a nap? What if I just went to bed? Okay. Well, basically, what they're trying to tell me also this question is a lazy bastard. Okay. Okay, let's relax. I've been playing ADOM Dungeon of something, and it's a hack type game where you run around and you beat up people. Fun because I always like to net, so I get to have more. Actually, I really hate these types of games. Just die too easy. Except by adding a like a cheating something. So Okay, after learning all that information, you go up like this. 1, 1, 0, 0. So it goes up like this, y equals x4. Now, I think what you're supposed to do is 2x plus e of y, I, y, of xe along the indicated curve. I think what you can do here is replace y with x4. And then, and from there, I have no idea. It's e of 4 plus 4x4 xe x4. What I can do is take the integral of this and find it along the indicated 1, 1 to 0, but basically going to be 1 to 0. So basically what I want, it's going to be x squared plus x plus over 5x 5. Going to be y plus x squared. That do in 1 0 0, which is basically from 1. So 1 plus -1. Why did I put y back? Am I stupid? Yes. Yes, I am. Very stupid. Idiot. Fool. -3, -4x cubed. Gotta clean it. Now it's a mess. X squared minus 4x cubed e negative x4 plus 4 over 5 x5 minus e negative x4 minus 3x 4x cubed, which leads to plus 4x cubed, which is 4x4 e x4 negative x4. Now it's going to be from 1. So here's 1 minus 4 1 e negative 1 plus 4 over 5 1 minus e negative 1. Actually, it's positive 1 because no, it's still negative. Idiot. Stupid idiot. Plus 4 e negative 1. Okay, so what the idea is that this minus goes away, this goes away. You get 4 over 5, you get 1. You get 1 plus 4 over 5 minus e to the power of negative 1. There's my answer. Might as well just take this. I might as well just take that and submit it as my homework. Since this is it. Probably wrong. I can imagine that's correct. However, I'm gonna go to bed. Gotta show that the given is independent path. Okay. Okay, boy, I skipped it. Reading the textbook is always fun before doing the problems. Or I can just go look. Watch. You did it right. A lot of porn on this website. Care at all. Okay. That's fun. A lot of. Okay. Now show that the given integral is independent of the blah 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 2 4 8 1 1 1 y z dx x x y. Okay. Hold on, my camera's yellow. Cause that's what happens when it turns 9 o'clock. Okay, it probably is not gonna show on the YouTube video, on the stream video. Okay. Y x z plus y x z plus y x. They're all the same, right? Now they want me to show that it's. Now they want me to show 2 times 4 times 8 is what? 60, 64, 64 minus what is basically 3. It's 128, 64, 12, 6, 92 minus. I go look at the answer. 63. I think I'm gonna. Given. It's a valid potential to use it. How? How to? It's conservative. There are no tricks. Why am I? Okay. Well, if I complain, stupid, I'm gonna get. Let's skip to the next part, and we're gonna cover double int. Should I put a timestamp? Put a timestamp. Click on it. This is 29:30. Should have. Okay, basically this is just a two-dimension int. And then we're gonna go look at triple integrals, but first we have to look at double integral and Green's theorem. Basically, I already studied a bit of this, but I'm gonna have to read it again. Also, I think I went over this already. No. Mentioning it. Okay. Volume's the same and properties double in basically the same as it's good to review, I guess. By stuff you can take it out, add them, you can separate the integral. Okay. Basically the concept is that it's like this weird thing where R1, R2, and separate them. Wow. Type 1 region. So basically the idea is, yeah, I did do this. And it's like this. It's like funny on this y-axis, it's a type 1. If it's funny on the x-axis, it's a type 2, like curving and stuff. It's like the best I can explain it. Iterated integrals. You do something and then yes, it works. Okay. It's a region of type 1, you do dx, and if it's a region of type 2, you do dy dx. Hold on. This is the Fubini formula. Fubini's theorem. Okay, well, they're drawing some complicated shapes that I don't understand. So basically, it's gonna be impossible. Am I even learning anything? I need to do some real reflection because I didn't learn anything independent paths chapter. It's on the thing and it's gonna be in the exam, so I'm gonna have a lot of trouble. Here, basically, I already did the evaluate the integral of x y over the region of two integrals, and since the function is of x then you should do you're supposed to do the function first, so I guess you're supposed to x equals y minus 5 negative, which x equals 5 minus 1, then do x equals, got 5 minus y, x here, you have 5 minus y and y here, got 2 and 1 here, because it goes over the graph of this and that, over the graph of y equals 1 and y equals 2. So now what we have to do is integrate it with respect to y and how are we going to do that? Yes, I have to pull out e, pull out 3y. You have to do it with respect to y and then with respect to y, x, and then y. So e plus x, e, x plus y, 5 minus y, 5 minus y, every x, y, it's 3y, minus y, e, y plus 3y. Got well, you got 5e, 5 plus 2y, minus ye, 5 plus 2y, minus ye 4y. Now you subtract it. Now you're supposed to take the integral of this with respect to y, which it's already in 2 and 1. So now you take 5y. You're supposed to integrate it too, so basically I did everything wrong. Wow. I would do this. Sorry, I give up. Dx and dy. So basically what I did was I got the formula right. I just have no idea how to do it. It's easy when you're looking at it. I got the equation right. I didn't get what's left of it is right. So I should probably refer to like an integral calculator or something. Okay, I have to solve this problem. Useful to visualize the double summation process. Got it right by accident. Okay. Reversing the order of integration. Okay. have them. Ah. Okay. So what we're gonna do is take a nap. I'm really struggling a lot with the double integral. Double in because you would think it's in a 2D space, but actually it's in a 3D space for some reason. It's a pretty next section we look at how to compute iterated. Okay, I'm saying it. Help me probably. Mass. A lamina, like I don't even know what you guys talking about. Oh, I shouldn't have. Okay, well, include a timestamp if I can't do it anymore. All right, I'm cooked. Off on that thing. I come back to do. Come back. I I need guess I need to review a little more. Was this thing even picking up my voice? Whatever. Bye.